Hey, good morning, everybody. I'm Andrew Hobbs from Better Indoors. I'm the Managing Director of the company. Thank you very much for attending our session on creating COVID-secure homes using our Active PIV process. I expect this will take around 30 to 45 minutes or so. I've got a few slides that I'd like to run through first. And then we have a chat box. If any of you have any questions, please type them in. And then once I've reached the end of the slides, I'm going to move over to a different screen, and hopefully any questions that I see there, I'll answer. Okay, so that's the format. Again, thank you very much for attending, and let's make a start. So the first slide, excuse me, 1 second. Let me get. Okay, so this is a very specific process. The COVID-19 problem for domestic properties, obviously, ever since the pandemic hit, people have been concerned about transmitting COVID, and the official primary mitigation is to increase ventilation air change rates inside properties. Now, for homes, that's quite a simple thing. Ventilation is universally available, so all you really got to do is just go and open a window, and that's really what much of the messaging has been since the pandemic started. But the problem with that is that it doesn't always work. We're seeing lots and lots of, we're in this third lockdown right now, and it's not really as simple as that. And the purpose of this really is to sort of help give you a bit of sort of like a technical understanding of why. So if I move to the next one. Firstly, a sort of brief explanation of how modern British domestic properties are ventilated. We describe the vast majority of British properties are built to what we call minimum ventilation standards. Now, in the building regulations for Part F ventilation, there are a number of strategies in there that every property has to, well, a property when it's built has to be given a ventilation strategy. The most common is System 1, which is intermittent extraction with background ventilators. The reason why it's the most common really is because it's the cheapest and easiest thing to build. Now, what the background ventilation aspect is, it relies on natural means, it relies on natural means. And this is where part of the issue comes from in terms of dealing with the COVID problem, because background ventilation performance, when you're relying on natural means, is far less predictable and reliable, and it's also far less energy efficient than alternative methods. Okay, so for properties that have System 1, which is the vast majority, as I've said, during occupancy, so when the properties are being lived in, you quite frequently see problems of underventilation, especially during the colder months of the year. And the reason for that is because the background ventilation process is very dependent on the behaviours of people. They've got to want to open up the windows or open up their trickle vents. Quite often during winter, people don't do that because it makes the house cold, it costs them money, makes them uncomfortable. And these behaviours, okay, will then, if you don't open the windows to create the ventilation, you get problems associated with underventilation. So many of you will be familiar with these. You've probably had lots of calls during the winter. It usually starts around October time. People complaining of water streaming down the windows, condensation, mold growth, and maybe other problems. So people that might have asthma or lung issues, they start to get worse perhaps during winter, even during summer as well with hay fever, but also problems of odours. And now we have the problem of COVID transmission. So the consequences of these problems are, again, you'll be familiar with all of this, health issues. Properties can get damaged by mold growth, and your tenant's very unhappy, and it costs you time and money to deal with it. So presumably you will all be familiar with these problems. Okay, so what can be done about it? So I've mentioned that at the beginning, we have a process of Active PIV. Now, PIV, the ventilation component of Active PIV is called positive input ventilation. Okay, When you open windows at the moment, it's a behavior dependent process. It doesn't guarantee to increase ventilation rates, but positive input ventilation will do exactly that for you. So it's basically an alternative method of ventilation that essentially removes the behavior dependency, and it's a mechanical process, so on. So it's far more predictable and improves performance. But so you need to remember that when you are increasing ventilation rates per the guidance, ventilation itself is a physical process. It's what we call a dilution and displacement process. And what it will not do, it may well blow viruses around. It may well blow a virus out of a window, but it will also blow a virus around in the property. So it's actually quite possible for increased ventilation air change rates to increase or at least keep the risk of transmission the same, because the viral emissions, when they come out of people's mouths, okay, are not killed immediately or not expelled to atmosphere immediately. Ventilation will not destroy a virus, it will just blow it around. And similarly, if somebody touches a virus onto a surface, that virus will remain alive on that surface regardless of your ventilation rates. So as part of COVID mitigation, ventilation may well be a step up from natural background ventilation. Okay, ventilation may well provide a more risk-less environment, but you still have a high risk because the viruses are not killed. So what's really needed is something that might kill the viruses at the point of transmission, as we say here. Okay, so before I get onto that, just want to give you some information about what is positive input ventilation. So I said it's a method of increasing the background ventilation rate in a property from natural means. Okay, it was originally conceived as a retrofit strategy, energy efficient retrofit strategy to improve building ventilation performance without the need to open windows. Okay, that's it was originally conceived, incidentally, in the early 1970s, excuse me, when we first started double glazing after the rise in the wholesale cost of energy after the oil crisis. Positive input ventilation is a whole home process. It doesn't require ductwork, very quick and easy to install, and it's quite affordable. Some of you may be familiar with positive input ventilation, and if you are, then presumably you will agree with what I've just said there. As I've just said there, it's been increasingly popular ever since we started to improve the insulation characteristics, going back to the early 70s. That's when we first started double glazing. But since then, other insulation characteristics like cavity wall and loft insulation have just basically improved things. And obviously, since we joined the Paris Accord with the climate change and carbon reductions, insulation characteristics have increased still further. So input ventilation, positive input ventilation, is a very reliable and predictable process. It removes any dependency on behavior, and therefore it will solve very effectively the problems of under ventilation at any time, but mainly during the winter months. So you therefore will avoid the consequences. Point to mention, though, that PIV must be properly specified and installed, and it's not always the case. So sometimes people have installed positive input ventilation, it's not been installed properly, and they blame the process rather than the installation. Positive input ventilation is also one of the widest used mechanical strategies in Britain today, with thousands of installations occurring in both social, basically in the public and the private sector housing. I think that's a very important point. It's increasingly popular, especially in the retrofit market. So when we look at this from a sort of home improvement perspective, those of you with large property stocks will know that what's most important for those properties is being able to fit improvements to the existing buildings rather than the new builds of your portfolios. Positive input ventilation is a recognised strategy in Part F. It's one of the alternatives. System 5 is mentioned in the regulations. And the regulations require that if PIV is going to be used, that the units must be certified to meet the requirements of the approved document F. And it's a very important point to mention here. There are numerous options of input ventilation from various manufacturers in the market, but there's only a handful of UK manufacturers whose products have been certified, which is quite an expensive process to do, incidentally, and the barriers to entry, as I call them, are quite high. But as I said earlier, just increasing the ventilation rate with COVID doesn't necessarily mean that you eliminate completely the risk of transmission, because the virus is still alive. So we need to go further, and this is where the concept of active PIV comes in. So what is active PIV? So it's a positive input ventilation solution that incorporates a technology called photohydroionization. And what this technology does is it leverages the mechanical airflow of the input ventilation process to create point of transmission protection against COVID and any other viral and bacterial emission. It also treats pollution that comes in from the outside as it goes into the property, and it will treat pollution that originates inside the property as well. For example, volatile organic compounds that may originate from furniture or cooking or household items are broken down and destroyed by this process at the point of transmission or emission. So it's a very unique and effective addition to the dilution and displacement process of ventilation that PIV creates, which of course is in itself a step forward from natural background ventilation. Okay, so photohydroionization, we describe this as providing an extra layer of protection to indoor environments beyond the capabilities of ventilation, and also the passive air treatments that are also mentioned in the COVID mitigation guidance. It basically says in there that you should use ventilation, but for any dead zones, you should use filtration or UVC systems. Now, these types of technologies are what we call passive. Therefore, they rely on the pollution and the virus to be moved to them, okay, before it's treated or removed, okay, and therefore the risk of transmission at the point of transmission still remains. You do not have that risk with photohydroionization. The virus is destroyed the moment, okay, it is issued onto the air, whether somebody speaks it out, talks it out, or touches it onto a surface. So active PIV can be retrofitted into, this is an important point, I think, any of you that might already have properties that have had positive input ventilation installed in the past. We can not only retrofit into those existing PIV systems or MVHR systems, but obviously we can also include it in any new specifications for new problems that you're solving. And then similarly, the final point here is that the photohydroionization process can also be installed separately. So if you have properties that don't need ventilation improvements, they're already sufficiently ventilated, but you'd like to create that extra layer of protection, then we have standalone units that can be deployed in domestic buildings for that purpose. Okay, so another slide here. What is photohydroionization itself? So here's a few bullets for you. It's a non-chemical process that imitates the natural air cleaning processes that are constantly happening in the atmosphere. Excuse me 1 second. But indoors. Okay, so that's what that is basically in the atmosphere for the last 3.5 billion years or so on this planet. Whenever there has been sunlight, water vapor, and oxygen present, there's a photocatalytic reaction that produces ionized hydroperoxide molecules in the air, hydrogen peroxide basically, H2O2. Now that is a very effective oxidizer, okay? As I said, there are very small concentrations of hydroperoxides in the air. Right now, if you go outside, you'll be breathing these in, and obviously therefore it's completely safe. Hydrogen peroxide is a very effective oxidizer. When it comes into contact with organics, it breaks them down. And what is the natural aspect of this process is that after the organic has been broken down, the hydrogen peroxide molecule will revert back to the component, harmless component parts of water vapor and oxygen. And that's the natural part of it. Obviously, if it was a process that created harmful byproducts, then life would never have evolved on this planet as we know it. Okay. Now, Photohydroionization creates an equilibrium concentration of these molecules throughout the indoor space. Okay, and that's the point. So once it's running, okay, once you have it within the PIV system, the molecules are distributed into the airspace, and the air is filled with these molecules. And that's where the real-time protection against viral emissions comes from. The moment that you sneeze, it's the air itself that's treating the emissions. Okay, so it's perfectly safe to breathe, as I've said. The concentrations produced by the photohydroionization units are basically similar to those found in the outside air, which is about 0.01 to 0.04 parts per million, or 1 to 4% of the current workspace exposure limits in the UK of 1 part per million hydrogen peroxide. As a process, it's effective across all 3 pollutant categories. So microbials, which is obviously where we want that real-time protection. So not just COVID-19, but SARS and MERS and every virus and bacteria you can name. Further down, I've got a number of slides that talk about the efficacy, but this technology is thoroughly tested in many dangerous, deadly, and other types of microbial. But it's also highly effective against gases, VOCs, and particulates and smoke. So as an addition to the ventilation, dilution, displacement, you're getting these protections as well. So how it works, it's basically a disinfection process. Any of you that understand what cell lysing is, it's simply a process that breaks down the plasma wall of a cell to expose the DNA, and then the cell is deactivated. And this is basically what happens with the photohydroionization molecules. It's exactly the same as what happens when you wipe a surface with Dettol. It's just that the concentrations of this process are safe for people to breathe. Okay. The process treats both the air and surfaces. I think obviously this is rather important. So basically any part of the indoor space that's exposed to the air, even if it's a dead zone, our process with positive input ventilation is capable of reaching to any part of the house. And obviously we have the standalone units for any areas that can't be reached. Okay, and this is very important because obviously viruses can survive on surfaces. Once they get onto a surface, they're no longer airborne, they're not going to be affected by ventilation. Okay, so having a process that provides that protection across the board is important. So it's a real-time, instant and continuous protection against emissions. So people in properties are basically have this extra layer of protection. And for what it's worth, we've been running photohydroionization here in our house for the last 2 years. We don't have colds or illnesses or anything like that. And it's a kind of bit of a thing of the past for us, even though I have a little daughter who goes to a school, and we were very used to getting colds certain times of the year. Okay, so to reiterate that point, photohydroionization kills viruses at the point they are transmitted. And then the final point with this is that it's not a new technology. You may be thinking that this is new and it's perhaps a bit of a novelty, but actually photohydroionization was developed and invented it's actually in the late 1990s originally by an American company called RGF Environmental, a 35-year-old environmental innovator and manufacturer. And it's today, PHI, photohydroionization, is used in over 60 countries in more than 5 million installations. So there is absolutely no issue as far as efficacy or safety. It's been tested and used across all types of application, residential, commercial, and industrial. So to summarize, PHI, photohydroionization, creates this continuous environmental effect throughout the indoor space, which adds an extra layer of protection beyond ventilation, any other COVID mitigation that you may have in place. It's a process that's not behavior dependent. It just works in background. So it's always working, and that's the extra layer of protection. And it ultimately creates safer and what we call future-proofed environments. Okay. So why is it different to other methods? Or what I mean here by other methods is the passive methods. So as I said earlier, passive systems will only treat pollutants and viruses that are in the air that are passed or moved close enough to them. So with filtration, obviously you've got to get the pollution or the virus to the filter. The same thing goes for ultraviolet. Some of you may be aware of some of these UV systems are getting a lot of airtime at the moment, you know, upper room, far UV, things like this. Now, ultraviolet is a passive process. It's a process that's very, very conditional. The performance of it is very, very conditional. It depends on how far you are away and whether the pollutant is moving, and whether there's any shadowing or anything like that. None of these problems apply with photohydroionization because it's an equilibrium process, and it's the molecules are distributed throughout the entire airstream, so it's not reliant on light. Okay. Other problems with passive air treatments is that you get no protection against foam-like surfaces, and there's also no guarantee that any of the pollution would get removed when it passes by or through the unit. So as a sort of a process in terms of its attributes against passive, it's we would argue that PHI perhaps offers an extra layer of protection, but it's very important for me to mention here that we ask people to consider PHI as an extra tool in the box. There are numbers of mitigations, some of which are more effective than others, as I've just described here. But what we're not saying is that you should do away with everything and say and use PHI. It's not the responsible thing at this time to be doing. All we're doing here is highlighting and showing what are the attributes of PHI against other technologies. Okay, so I've got some slides here, some pictures here now of the what the units look like when they're installed. This is an active PIV system. It's just a positive input system, but with the PHI process installed. So you can see here we basically put it inside the duct. This is a close-up, and this is what the cell looks like inside the run. So the air is filtered from the loft space by the unit, is pushed down the duct, passed over the PHI cell, and the oxidizers are enriched onto the passing airstream, and then it's blown out into the rest of the house. So this is a good example of a loft-based PIV system, active PIV system, and the property in which this is installed obviously benefits from the distribution of those oxidizers throughout the indoor space. Excuse me. Okay. The next type of active PIV product is for properties that don't have loft spaces, so flats or properties without lofts, basically. And again, you may be familiar with some of these. We have wall-mounted units that can be where we duct the airflow to the relevant places or places of delivery. And what we do is with these installs is we locate the PIV process inside the duct run. So as it works with loft PIV, the oxidizers are distributed onto the passing airstream. Now, this final slide here, incidentally, this shows when we do our installs, we can hide the units away. We use products from a manufacturer these are the smallest, most compact units on the market, and the whole lot can be hidden away. So you can make your wall unit installations look as best as possible. There's no units visible basically once it's been finished. Okay. Now this third screen, this is an illustration of some standalone installations that we've done. These are actually commercial premises, but the same would apply in a domestic property. These are our standalone units. You can see here they're either installed on a wall or a number of dentists that we installed recently, or on ceilings in offices. So just to remind you, this is where you may want to have that extra layer of protection in a building that does not need ventilation increases. And not all domestic properties do, so some do where you've got visibly evident problems of insufficient ventilation, like mold and condensation during the winter. Okay, so there's just a few photographs here of what those standalone units look like. And then I've also included this slide, which is our commercial business. We are doing a large number of, an increasing number of installations, some really high profile projects like Lloyd's of London, and other big buildings in the city right now, in central London right now, where building owners, company managers are looking to create the best possible protections for their staff as we come out of lockdown. So our products are getting are being installed in increasing numbers of commercial spaces to create that extra layer of protection as people start to think to come back to work. All right, now I've put in here this case study, which I think is highly relevant. This is quite recent, and this relates to an installation we did in Hounslow it was about just over 2 months ago, 2 or 3 months ago now. We received a phone call from a lady, vulnerable person with low immunity, and she told us that on that particular day, her son had just been diagnosed with COVID. She was worried for her own health. And she told us that opening windows is not really an option for her. She doesn't have very much money. And she's worried about the guidance that she's being asked to follow. She'd read about our products and asked whether our products would help. So we, because she was a tenant, we said to her that there's not much we can do if the landlord won't invest. It's a private property, by the way, not a social housing property. If the landlord won't buy input ventilation to improve the ventilation rate, but what we can do is install one of our standalone PHI units. So we went over there on that day and installed it for her. And basically what happened was 3 days later, she called us back and told us that her son's symptoms had gone. She also told us, by the way, that her other son, who sleeps in the same room as the guy with the COVID infection, all of his asthma symptoms had also eased up and basically gone away, which she was delighted about. And then after 30 days, she told us that all of the members of her family had had 5 COVID tests each, and nobody had caught the virus. So this is very important. It's a property that relied on natural background ventilation, a family that wasn't wearing masks, was not opening windows, and yet with the installation of our equipment, it just proves and shows that the virus was unable to transmit, even though none of the mitigation measures were being followed. Okay. All right. So just to, I suppose, summarize then, the key benefits of Active PIV for domestic is it stops the viral R rate increases throughout indoor spaces. It improves the indoor air quality, which leads to improved health and well-being for your tenants. It will significantly reduce energy costs, and I think this is a big point in the context of the current mitigation. When people are being told to open windows, that can be very costly, and that can cause all sorts of difficulty and financial hardship. With Active PIV, there is no need to open windows during the colder months of the year. The property will be fully sufficiently ventilated, and you will have that extra layer of protection, okay, against COVID transmission from this. The positive input system also, incidentally, does improve energy efficiency because for loft units, we can leverage the solar gain, which can lead to basically a recovery of about 500 free kilowatts of energy per year, according to the Energy Saving Trust. Okay, so our units create an added layer of protection, for all sorts of people, including frontline workers. So it creates safer, healthier indoor environments, which builds confidence in indoor spaces. So your tenants, if you start installing this in your portfolios, word will get around, and that's a potential benefit. We have products, like I said, for all types of property, and I think this is quite important. So if you've got a big portfolio of property already that's already got positive input ventilation or MVHRs installed, we can retrofit this into those systems without, with ease. We don't. It's not a difficult issue at all. The units can be installed very close to where the ventilation systems are, or we can install the standalones. All right, so it's very quick and easy. It's also very affordable. As I mentioned, my company offers lease, rental, and hire purchase options as well for block installation projects. And we don't have any issue at all with the supply either. Rapid procurement is available. Okay, so that's kind of like the high level. Now I have about 10 more slides, which I'm going to quickly run through. Everybody will be able to have a copy of this slideshow. We're recording it, and this presentation will be put up on our website. It's just a little bit more detail about the technology and safety and efficacy. So firstly, the technology inside, just a bit of background here really. It was invented in the late 1990s. It originally came to prominence in, after 9/11, when the US government was worried about viral exposures on airliners. It was around about the time of the anthrax scare. And RGF, the manufacturer, was involved in that project, and they presented photohydroionization as a solution for protection inside the airliner cabin, before the virus had reached the filters. And they were asked to prove the process, which they did. They went away and developed a mechanical sneeze machine, a nebulizer of viral emissions, and they created an experiment which showed a 99.9% reduction in everything that was emitted from the nebulizer immediately within 3 feet. And that's obviously a test that we have information on if you want to see. That's a double-blind test, incidentally. 2 years later, the SARS epidemic hit the world, and the Chinese government ordered a large number of units for some of the public buildings in China. There's been numerous tests ever since. Like I said, there's more than 5 million installs that's happened since then. So this is a tried and tested process. You're probably thinking about, is it safe? I mentioned earlier that the the ionized hydrogen peroxide production is basically similar to the outside air. That's correct, that's true. We have some of the testing that's been done where people have measured the concentrations. It never goes anywhere near the thresholds, even in fixed, unventilated, small chambers. So there's absolutely never a safety issue, never has been a safety issue with the products anywhere in the world. And RGF's technology was one of the world's first to comply with the zero ozone standard of the state of California. So over there, it's the only jurisdiction in the world that's legislated against air cleaners that produce high levels of ozone. Their threshold is 50 parts per billion, so 0.05 parts per million. That's the mandatory threshold above which no air cleaner can go. And incidentally, if you're interested, take a look on the California Air Resources Board website. There are 2 lists on that website that publish both safe products and unsafe products. And you'd be actually quite surprised to hear that there's a number of products that are being sold right now here in Britain that are on that unsafe list in terms of ozone. RGF is not one of them, incidentally. Okay. Now, the mandatory standard is 50 parts per billion, but they also offer, ETL Intertech also offers a test that is 1/10 of that mandatory standard for anybody who wants to really show that their system is producing almost no ozone. And RGF's technology was the first to comply with that zero ozone standard. So that is 5 parts per billion. And for anybody that's interested, the ambient ozone levels in the outside air in the United Kingdom for the last 12 months ranges from about 30 to 40 parts per billion. So, we're producing far less ozone than we're always breathing whenever we go outside. So there's never an issue with safety with these products. They're completely safe for people to use. And there's never been a safety issue anywhere in the world in more than 5 million installations. Excuse me. The next point is the efficacy. So RGF's technology has probably been the most scrutinized of pretty much all air purification technology that I'm aware of. And this is, I think, a very important point, especially with SARS-CoV-2. Since the pandemic hit, RGF has performed against the actual SARS-CoV-2 virus. These all started sort of September to October 2020. And the aerosolized testing that they performed on the actual SARS-CoV-2 virus with this technology is completely unique. Doesn't have any equivalent in any public health setting or any academic setting. What they did was they created an experiment where they located the unit inside a very large test chamber, about 8 feet by 20 feet by 20 feet. 8 foot by 8 foot by 20 foot, I should say. So 1,280 cubic feet. They located various collection plates inside the chamber. They put the units in there. They created some control measurements first, and then they turned the units on. And they looked at the reduction of the viral titer on each of the collection plates at various time intervals. And the experiment proved that no matter where you went inside the chamber, you were getting the same reduction effect. So in other words, it proved that it's an environmental effect. It's working throughout the entire space. Any of you that have been reading up on some claims made by other manufacturers recently, a lot of people have kind of like been a little bit misled by some of the dubious claims coming from some companies. There's one bipolar ionizer manufacturer who's currently being sued partly because of misleading information about testing. So our RGF really does kind of stand alone for these tests because the technology is so unique and it's so effective. But basically, if I just quickly run down here, the efficacy covers numerous deadly viruses and bacteria, so SARS-CoV-2, H1N1, E. coli, Listeria, strep, tuberculosis, bird flu, and many others. There is a booklet of test results available both on the RGF website and on Better Indoors website for those of you that might be interested in understanding which organics it's been tested against. But it's worth saying that because it's a disinfection process, it does not matter how many times the COVID virus mutates. Any virus, even an envelope virus like this, will be subject to the same disinfection process. Okay, it's always going to be effective. This is another great benefit of a technology like this. Okay, further down, it's also highly effective against odors because odors are simply organic molecules in the same way that bacteria and VOCs are. So it's the same process that breaks them down. But as you can see further down here, there's numerous areas, commercial entities or public sector entities where this has been tested. Some of the tests, incidentally, have not been funded by the tests have not been funded by RGF. They've been funded by these customers. You can see here the US military, various hospitals, which reduce very rapid drops in acquired infection. Various schools report reduction in absenteeism, and so on. So it's quite an important feature of the RGF technology, this, and there's plenty of information on the website. Okay, I think it's just an extension of the previous slide here. But I mentioned about the sneeze machine kills all the germs within 3 feet, and the reductions that we achieve with the testing with the innovative bioanalysis. There are only 4 more slides left, so I'm nearly finished here. I've got 2 slides on 2 large commercial studies. What you're looking at here is the testing that was done by these companies. In the case of the Lloyd's building in the city, which presumably you will be familiar with, it's a very unique building right in the middle of the city. Excuse me. What Lloyd's wanted to do was to test the effect of the process before they decided to roll it out. So what we did was we helped them design an experiment for an entire floor. So over 4,600 square meters. We simulated the production installation, and we told them to take random measurements. We didn't want them to tell us where they were going to be, and that's what they did. And the results were sufficient for them to decide to roll it out across all of their UK estates. You can see here a 97% ATP reduction. ATP, incidentally, is the metric used by many cleaning companies to determine whether surfaces are clean. The next slide is one of our other big recent projects. Mishcon de Reya is a very well-renowned legal services company. Their head office is right next to Holborn Station in central London. And in this instance, the testing for Mishcon, which was very recently, by the way, we did the installation there in January. But they were a lot more comprehensive in terms of the testing locations. They had about 35 locations. And again, the technology stood up to the scrutiny it was placed under. Okay. This slide here is just to give you some idea of some of the other environments where this technology is currently being used, and not just in the UK, but elsewhere in the world. These are some projects that, if you look them up online, you'll find more detail. But just to give you an idea, it's being used in schools, leisure centres, hospitality, all sorts of commercial environments. healthcare systems, mass transit, inside vehicles, so on emergency vehicles. It's used in school buses. It's used in all sorts of commercial environments, like I've said. So it's a tried, tested, and proven technology. So translating this back to active PIV in homes, it's entirely safe. So the last slide here is just a background of RGF and us. RGF, like I said, is a 35-year-old world leader in environmental manufacture. They make currently over 500 products and hold currently over 32 active patents. They've invested huge amounts in the last 12 months since the pandemic hit because of the enormous demand that they've experienced, and they're currently employing about just over 700 staff. It's a COVID critical manufacturer as well. This is something that they were designated by the US Department of Homeland Security last year. So it's a manufacturer that is really peerless in this space in terms of creating technologies that provide these sorts of protections, which are now suddenly en vogue with the pandemic. Okay, so that's the end of the presentation. Thank you for listening. I'm just going to nip across to the slides here and see if we've got any questions. Just 1 minute. Close that, I think. Okay, well, I don't see any questions. I will leave it a few more seconds. Just have a sip of my drink. If I don't have any more, I'll be ending it. But thanks so much for listening. Just 1 second. Let me just see if anybody asks a question. All right. I don't have any questions. Thank you for listening. And we'll be putting this recording up on our website. Thank you very much. That's it.